Good morning. Today our lesson is on scientific notation. You don't actually have this slide, but this is just an introduction, then we'll start actually solving some problems. So first, scientific notation is a way to write really big numbers or really small numbers in an exponent form so you don't have to write them all out. So these numbers have the form c times 10 to the power of n. C is just a number that's between 1 and 10. So we have some number, it's going to most likely be in decimal form, like for example 9.5. That's between 1 and 10. And then it's going to be times 10 to the power of some exponent. That number up there, n, is an integer, it's a counting number. It might be 10 to the power of 4, meaning that you're going to multiply this number by 10 4 times. So 9.5 times 10 times 10 times 10 times 10, 4 times, and that will give you your answer. So we're converting between scientific notation, and then the solved form is called standard form, just like we write normal numbers. We can move between either way here. We can go from standard form to scientific notation, or vice versa. Our exponents here are positive or negative. Now, if it's a positive number, it's going to be a really big number because you're multiplying by 10. If it's a negative number, it's really going to be a small number because you're really dividing by 10. Because this is a negative exponent. We didn't really learn this, but negative exponents would be moved to the bottom. So it would be 10 to the power of 4. You'd be dividing by 10 4 times. So it would be small, 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 small. So these numbers are going to be small if they have a negative exponent, and they're going to be big if they have a positive exponent. So how do we move from standard form to scientific notation? I'm going to write up here c times 10 to the power of n. C again is just that number that's between 1 and 10. So we need to figure out what number could we go here that we could multiply by 10 multiple times in order to get to our answer. So right now our decimal is right here. Now if we move over one time, that's like multiplying or dividing by 10. So we can move our decimal 1, 2, 3, 4, 5 times would get us a number. Now if you look at this decimal, it's between the 4 and then 0.5, so it would be like 4.05. That number is between 1 and 9. I'll make that a 9. That number is between 1 and 9, so we're good. If you only moved it over one less time, that would be 40.5, and that is not between 1 and 9. So we needed to move our decimal over enough times to get a number out front that's between 1 and 9, and that is. So then it's times 10, and however many times we move the exponent, or move the decimal, that's our exponent. So we're multiplying this number over and over and over and over and over again. So it's going to be a big number, it's a positive exponent. We move this decimal 1, 2, 3, 4, 5 times to end up right there. So our exponent is a 5. There we go. Let's try another one. Right now our decimal's on the end here. We need to move it over until we get a number between 1 and 10. If we move it to here, we'd have 631, so we got to keep going. If we move it to here, we'd have 63.1. So we need to move it all the way over to here, so we have 6.31. So we're going to move our decimal 1, 2, 3, 4, 5, 6 times. So times 10 to the power of 6. We would multiply this by 10 6 times to get that big number again. Now we have already in scientific notation, we need to get to standard form. So I'm going to write this number, whatever's out front there, write it over here. Now we're going to move our decimal, there's our decimal, 7 point nothing, 2 spots. Since this is a positive exponent, it's going to be a bigger number. Also on your number line, 2 is to the right. So we're going to move our decimal 1, 2 spots to the right and fill in any loops with zeros. So this number is really 700. Same thing over here. Start with what you're given, just write it out. That's always step 1. Write out what you have. and we're going to move our decimal 8 times. Well, on our number line, 8 is going to be to the right. 1, 2, 3, 4, 5, 6, 7, 8. We're going to move to the right 8 times. So let's move starting right here. 1, 2, 3, 4, 5, 6, 7, 8. That's where our decimal is. We're going to fill in the rest with zeros. So it does not mean 8 zeros, it means move 8 times. So your answer is 3, 4, 8, 4, and only 1, 2, 3, 4, 5 zeros. If you want to rewrite it, you can, but you don't need to. That would be our final answer there. So if you have standard form, you just need to figure out how many times do you need to move the decimal over to get a number between 1 and 10. If you already have it in scientific notation, just write out the number out front and then move the decimal however many times it says. Same thing here, but now we're going to have small numbers, small meaning less than 1. These are going to have our negative exponents. So right now I know that this is a really small number, it's less than 1. I need to move my decimal here over to get a number between 1 and 10. So 5, if I move my decimal over here, 0.5 is not between 1 and 10, so I need all the way on this side 5 point nothing, or just 5. So I'm going to move my decimal over 1, 2, 3, 4, 5 times. So times 10 to the power of 5. This is the number that was out front, this 5. And we moved our decimal point 5 times, but it's a small number, so it's a negative 5. Let's try another one. We need to move this decimal all the way over here somewhere till we get a number between 1 and 9. If I move it way to the end, that would be 6301. That's not between 1 and 9. If I put it here, that's 630.1. That's not between 1 and 9. I need it way over here, 6.301. We don't need to include any of the zeros unless it's between two numbers. So we need our decimal to get between the 6 and the 3. So we're going to move our decimal 1, 2, 3, 4, 5, 6, 7 times. It's a negative 7 because it's a small number. It's less than 1. Going the other way as well, start off with what you're given. 7. The decimal's right there to begin with, the whole number. We're going to move 2 spots in the negative direction. Well, if you look at our number line, -1, -2, that means we're moving to the 1, 2 to the left. So our decimal point needs to go to the left 1, 2 spots and fill any loops in with zeros. So our answer is 0.07. Last one, start off by just writing what you have. 3.106. And our exponent tells us how many times to move our decimal point and in which direction. Negative numbers are to the left, so we're going to go to the left 8 times. So from here, 1, 2, 3, 4, 5, 6, 7, 8. Put a dot there. It's our decimal. And fill in all the loops with zeros. So our answer is now 0.0000003106. If you want to write that out again, you can. But you don't need to. These are really the same number. We move the decimal over. Alright, we have 2 questions that have to do with scientific notation. It says, which number is this? Well, there's 2 ways you could do it. One, you could try and figure it out in your head, or we can use our calculator. Now, I'm going to plug this whole thing in my calculator, but when I do it, I'm going to make sure to put the top piece in parentheses and the bottom piece in parentheses because those go together. Because this right here means divide. We don't want to divide like 6 divided by 5.4. We want to divide this whole piece by this whole piece. So I'm going to plug this in my calculator, parentheses 1.728, and then times 10 to the power of, remember this up arrow means to the power of 6, parentheses, divided by, so I just did the whole top piece, divided by, and then in parentheses the bottom piece, 5.4 times 10 to the power of 8. End my parentheses. And I get an answer of 0.0032. Now this is not in scientific notation. All of our answers are in scientific notation. So remember, we need a number between 1 and 9, and then times 10 to some exponent. So if we just look at our answers first, 0.32 is not between 1 and 9, it's less than 1, so I can eliminate that answer right away. And I can eliminate this, oh, nope, that one's good, 3.2, 3.2, 3.2, those are all between 1 and 9. So we know our decimal has to be 3.2, we want it way over here. And we're going to move our decimal 1, 2, 3 spots. So I can already eliminate this one because it says only move 2 spots. So now I need to know, is it a positive 3 or a negative 3? Well, this is a small number, so small numbers have negative exponents. Or you can think from here, if we were to start over 3.2, we'd move negative 3, 1, 2, 3 to get back to our original. Alright, let's try one more. It says order the numbers from least to greatest. So I'm going to look here, and actually they're all the same numbers, just in a different order. So I'm going to actually multiply or write them out. This one is 3.5 times 10 to the negative 2 power. That really, if we write this out, is 3.5, and we're moving 2 spots to the left. It's a negative, so 1, 2, so 0.035. The next one is 3.5 times 10 to the power of negative 3. So 3.5, we're going to move this one 3 spots to the left. 1, 2, 3. So this one just has 2 zeros in front, meaning it's smaller. This one's a little bit bigger because it's less zeros in the front. And then our third number here, 5.3 times 10 to the negative 3 power. So this one is a bigger number up front here. We're going to move 1, 2, 3 spots. So these two here have the same number of decimals up front, 0, 0, but then so I know this one is bigger because it has a 5 and this one has a 3. And then this one right away, if you compare 0, 0, 3, 0, I know this one is the biggest. So right away I have to have this number on the end because that's the greatest number. So 3.5 times 10 to the negative 2, well, that's here and that's here. So I know that one is the biggest. We want the least number over on the left side. The least number would be this one in the middle because these two are very similar. However, this one has a 3 and this one has a 5 in the third decimal place here. So it's smaller than this one. Same with this one, it's smaller than this because 0 and then the 3, the 0 is smaller. So we better have 3.5 times 10 to the negative third first, which is that one. And then our middle one would be this bottom one, 5.3 times 10 to the negative third. So it looks like C would be our answer. Again, it might help to write them all above each other. 0.0053. And then you can see, okay, these are all equal. Oh, this one's the biggest. And this one here would be the smallest. And then that would leave this in the middle. Because the 5 would be bigger than that one. And that one's the smallest. So C would be our answer there. Alright, next we are going to look at slope. So in class I'll have a little video to watch, so make sure you pay attention to that. Otherwise, some things we already know about slope. We know rate of change is a fancy way of writing slope. This means slope. Slope is also rise over run. As a fraction, like this, like 5 over 3, that would be a slope, or negative 2 over 4, that's a slope. Some things we know how to graph. We know what an x-intercept and a y-intercept. A y-intercept crosses the y-axis, and the x-intercept crosses the x-axis. We've used the equation y equals mx plus b. We've used tables. All these things we know how to do, but we're going to focus on slope. Slope, remember, is counting rise up and down first, and then run. If you get confused, think of our elevator. An elevator, you have to go up and down first, then get out and walk to where you need to go to. So that is our rise over run. And it might help you too if you want to write out slope man on your formula sheet. That would be a good idea. So first, a little slope review. Finding slope. This is in the form y equals mx plus b. So m, our slope, is just right here, -5. Next, slope from a graph, we're going to count rise over run. So from here to here, I'm rising 1, 2, 3, 4, 5. And I'm going to run 1, 2, 3, 4. So my slope is 5 over 4. And then the third way is from 2 points. X, Y, this is my first point. X, Y, this is my second point. And we need to use the slope formula. It is on your yellow formula sheet. It says y2 minus y1 over x2 minus x1. It says slope of a line next to it. So we need to just plug in our points into this formula. So it says y2, which is 6, minus y1, which is a -2. Two negatives make a positive. Then on the bottom, x2 minus x1. So -3 minus x1 is also a -3. Two negatives there make a positive. So 6 plus 2 is 8. -3 plus 3, it's not 6. They kind of cancel each other out. A +3 and a -3 makes 0. Now, this is either okay or no. Well, we can't divide by 0, so this is actually undefined. Our answer is not 0. You can't divide by 0. Try it in your calculator. It won't let you. And then we have one more row of slope here. This one we need to solve for y to get into this form y equals mx plus b. So I'm going to move the x's over to the other side. They're positive right now, so I'm going to subtract 7x. Those cancel out. We have a -5y. And then our x's come first. You can't subtract those because they're not like terms. So just write them next to each other. And then finally, we need y by itself, so I'm going to divide by -5 because it's multiplied. We're not adding, we're dividing. So 5 over 5 is just 1y or just y. I know two negatives, when you multiply or divide, make a positive, so I have 7 over 5, and there's an x. I left that as a fraction because it's not going to be a nice number. Again, two negatives make a positive, and 25 divided by 5 is 5. So there's my equation, but they wanted to find the slope. So our slope is really just 7 over 5. In front of the x, that's our slope. All right, next two should go pretty quick. Finding our slope, we're just counting rise over run. So we're really going down -1, 2, 3, 4, 5, 6, and over 1, 2, 3. Well, we can simplify that. I know 6 divided by 3 is 2, so it's really just a -2 or -2 over 1 if you want to leave it as a fraction. Last one, we're going to use our slope formula again. I'll scroll up so we can see that. So I'm going to label my points x, y, first point, x, y, second point, and then let's plug them in. y2 is 4, minus y1, which is 9. Then on the bottom, x2, oops, don't write x2. What is x2? x2 is 0, minus x1, which is 6. So 4 minus 9, there's more negatives. different sign, subtract 9 minus 4 is 5. It's a negative 5. 0 take away 6 is still negative 6. So this is our answer. However, we know two negatives make a positive. So our slope is 5/6. All right, last slide here. It says plot and label the following points and then find the slope of each side. It says quadrilateral. Quad means there's 4 sides, so you know this is going to be some sort of shape that has 4 sides. So let's label our points. Here's y and here's x. So we're going to plot this xy. So x is negative 3, so 1, 2, 3 to the left, and up 1. There's A. B, x is 2, so 1, 2 to the right, and up 1, 2, 3. There's B. C is 4, 1, 2, 3, 4 on x, and then negative 3, that's down. There's point C. And last, negative 4, negative 4. So negative 4 is to the left, and then down 4. Take a second and connect your dots. This is our quadrilateral. And then we need to find the slope of each side. So we're going to count rise over run from A to B. So we're going to rise 1, 2, and run 1, 2, 3, 4, 5. Then from B to C, it doesn't matter if you count up first or down first. I'm going to do this one up. Rise 1, 2, 3, 4, 5, 6. And to the left will be negative 1, negative 2. I know 6 divided by 2 is really just 3, and it's negative. You can leave it as a fraction, 3 over 1 if you'd like. Then from C to D or D to C, it doesn't matter which order you go in here. I'm going to count rise 1, and then over 1, 2, 3, 4, 5, 6, 7, 8. So up 1 and over 8. And then last, from D to A or A to D, rise 1, 2, 3, 4, 5. Oops, that's a 5. And over just 1. 5 divided by 1 is just 5. So we found our slope of every side to the quadrilateral. So again, we're reviewing some and learning some new things for our MCA. The front side is working on scientific notation, and you get 10 yards for that on our football wall. And then on the back should be a review of slope, very similar to what we just did on our notes. You get 5 yards for that because that's a review skill. Regardless, both of these will be going into the grade book. So if you do both sides, show me, and I'll let you move your helmet 15 yards.